Let me start by introducing myself. My name is Gavin Gear, and I'm kind of your basic engineer, tinkerer type. I'm actually a mechanical engineer by training, and for a number of years have been interested in things like interfacing systems and PCs, and data acquisition, and building things, and experimenting, and adapting, and optimizing. So a few years back, when I was offered a program manager role on the team that was going to build the Windows 7 sensor and location platform, I jumped at the chance. And it's been really exciting to be a part of defining what this platform looks like and working with partners and innovating in this space. And over the last year, it's been a particularly big year for our team. If you're here at PDC 2008, you might recall that we made our first public disclosure by announcing this new platform. And you might have also been lucky enough to get one of these free Windows sensor development kits. It's pretty good swag. And in fact, you can go on freescale.com and order these online now and experiment with the platform and work with our example code, even firmware code. And actually, the first person that comes up to me afterwards and asks me, I have another extra free one. So if you didn't get on it last year, the story's not done yet. But it's also been a really good year of releases for our team and for Microsoft in general. Back in June, Microsoft launched Bing worldwide, which has really changed the way that people are able to search and get relevant results. It's got a refreshing new look and feel and UI. Bing cashback and other shopping-related features have really created new commerce solutions. But I think one of my favorite parts of Bing is the Bing Maps functionality. Because getting directions and finding points of interest and even using Bing Maps 3D has really proven to be a good user experience for myself. And then last month, we had the worldwide launch of Windows 7, which was really exciting for me, having worked on the platform and being really proud of what a good product this is. But it's also been good for our partners who are building innovative solutions on this technology. And looking forward to next year, with Visual Studio 2010 coming to market, it'll be another great year for developers as well. So today, we're going to take a look at how these three technologies, the Windows 7 Sensor and Location Platform, .NET 4, and even Bing, can be married together to create innovative new applications and unlock new user experiences based on sensors and location. But before we get started with that, I want to ask you a question. Have you ever been so excited about a piece of technology or a gadget or a piece of software that you just had to share it with your friends? You just had to tell your friends and family, this is something you got to get, or you got to download, or you've got to buy. And if you're really an enthusiast, you might have gone so far as to take screenshots or take pictures and upload them to the web and participate in discussion forums, that kind of thing. That's typically what I do when I get a new device I'm really passionate about, because I'm just that kind of enthusiast sort of person. And one of the times when that happened for me that comes to mind was a few years back when I got this Garmin 60 CSX GPS unit. This is a really cool unit, even 3 years later. It's got a Surf3 chipset, which enhances the reception capabilities of the device. It's got a crystal clear view anywhere, full color screen. It's got a micro SD slot inside so that you can expand your storage capability with maps and points of interest and all sorts of things. And it's even mud-proof and dust-proof and snow-proof. And I've actually tested all of those features with this device. I've even snowshoed backpacking with this, and I'll tell you, it really saved me, because I don't know if I would have found my way around without it. So if you're an outdoors person, this kind of a device can be really a game changer. It can open up new experiences and really make the most of what you want to do. And here you can see a picture of this very GPS device out north of Lake Chelan in the state of Washington, next to a remote location called Boiling Lake. And on my way back from this trip, I experienced what I frequently experience with my digital camera, which is I can't wait to get it home and connect it to my Windows PC so I can download information off of it and share it with friends and store it for future reference. So another thing I like to do, in addition to just creating views of tracks and 3D representations of the route that I was on and points of interest, that kind of thing, is to go in Bing Maps 3D and kind of relive parts of the trip. So on the left here, you can see a photo that I took on that trip at Boiling Lake, where I took that picture of the GPS. And on the right-hand side, we have basically a Bing Maps 3D recreation of that same exact vantage point. And what's really amazing to me is that they're able to take essentially aerial photos, satellite imagery, and raw topographic map data and reconstruct a 3D environment that is really very close to reality, even in the middle of nowhere, like here at Boiling Lake in the state of Washington. So this is really cool. Now I can go through and have friends relive parts of my trip or create new memories from using Bing Maps 3D. And another example that you might be more familiar with is some of the city level detail that you can get. So on the left here, we have a picture taken from Cary Park in Seattle, which is near where I live. And on the right-hand side, I've gone in Bing Maps 3D to the same vantage point. And with 3D building models and terrain data and imagery, we can see that we really have a very realistic recreation of this particular vantage point. And this can create great new experiences for customers, because now instead of showing points of interest or maps or routes on a boring 2D surface, you can now do this in 3D. So if you think forward to the next few years of progress, when you think of technologies like photosynth and other technologies, it'll really be amazing to see where all of this goes and to see the kinds of amazing new products and hardware that can unlock these new experiences. But what about location awareness on the PC? It's one thing to import location data and to use that data and maybe to store that data or share it with friends. But what if your PC or device always knew where it was? What if, while you were on your social networking tool, you could share your location optionally with friends that you wanted to share that location data with? Maybe it's just your city level detail or even your precise location. What if you could geotag files that represented where that file was created or modified? What if you could do other interesting things like implement pinpoint search results with increased relevance? For instance, if I want to order pizza for carryout, I probably don't care about pizza restaurants that are more than a few miles away. But if you know your pinpoint location, your search results could be pivoted on your current location, and therefore you'd see your closest results first. And that's likely what customers want. So by supporting location awareness, we can unlock new experiences, and we can also make existing experiences better. Have you ever tried to use a navigation application on a laptop? Anyone? Like with a GPS puck or anything like that? If your experience was like mine, it might not have been optimal. So this is kind of how it went for me. I take my GPS puck, I plug it into the PC, I start up my mapping application, expecting great things, and I wait, and nothing. So now I'm wondering, okay, why doesn't this just work? So I kind of root around in the UI of the application, and finally I find a configure GPS option. So I think, okay, I'll just configure the GPS and things are going to work. So I go through the process of scanning for location devices, and then when the scanning is complete, I have a couple of COM ports to pick from. So I've got like COM9 and COM13. And to your average user, this is pretty much meaningless. This is kind of like trial and error. So maybe I'll pick COM13, figuring that the higher number is better. And so I exit the dialog, and I wait, expecting great things, and nothing. So now I'm getting really frustrated. So I go back to configure GPS, scan again, wait for the scan to complete, and this time I see COM9 and COM13 again, but this time I'm wise to the system, and I know to pick COM9. So after exiting the application and waiting a while, finally my map centers to my current view, and I can get directions, I can see points of interest, that kind of thing. I think we can all agree that that type of user experience is definitely not optimal. But there are other challenges as well. COM ports don't have a security model. So if I don't want applications to know what my current location is, I've probably got to just rip the GPS puck out and just hope that no one's storing my last location, that kind of thing. They're also exclusive application access, meaning that the first application to come along and lock that COM port is the only application that will be able to access that data stream at that given time. So if we want ubiquitous applications on Windows with COM port-based devices, it's just not possible. And finally, we have proprietary data formats to parse. So if I'm implementing a location-aware application, I've got to do things like either find the right COM port, have the user select the right COM port, and then once I've got it, I've got to parse the data stream, which is probably NMEA, which is a marine data format, and it might even have third-party extensions, proprietary extensions. So all of this is kind of a lot of work to do to just support COM port-based GPS devices. And then you might be wondering, what about other forms of location-aware technology on the PC? We're probably all aware of IP lookup and Wi-Fi triangulation and cell tower triangulation. And if I want to add that functionality to my application, now I've got other SDKs or APIs to learn. And this is really both a lot of work and a moving target. New technologies come along, now I've got to adopt those new technologies. So in Windows 7, we've mitigated these issues by supporting sensor and location devices natively in the operating system. And what I want to do is give you a quick tour of what this looks like in Windows 7. Go to the right machine here. So here we have the Windows desktop, and I've installed a couple of gadgets that are capable of being location aware. So here we see a weather gadget that shows us the current weather for a location, and we have a points of interest app, desktop gadget that can show us relevant search results nearby based on a set of criteria. And the simplest way to support location on a Windows 7 machine is to go to what's called the default location control panel. So here, on any Windows 7 machine, we can actually enter our zip code, or if we expand this option, we can actually enter a complete address. And this would allow applications to know our pinpoint location. So if we wanted to order pizza nearby, if we've entered that information, you could use that address to find the nearest restaurant, for instance. You can also, by the means of a third-party plugin, do something like click on a map to find your precise location expressed as a latitude and a longitude. So I'll show you that real quick by running an application that we have on the MSDN code gallery that allows you to do just such a thing. So I'm going to zoom into where my PC is normally located. I'll just pretend I'm at work here. We'll zoom into Redmond. We right-click on the map. We'll see a couple things. First, we see our latitude and longitude in the default location control panel. We could also reverse geocode that and have the address shown here, and both of those data types available to applications. But notice here that our gadgets have also updated. So now we have the really poor weather for Redmond, Washington. I'll have to say I've been feeling like I'm in Tahiti down here. I kind of don't want to leave. And we also have points of interest. So here we have restaurants. And you can see there's a lot of Starbucks in the Seattle area, kind of dominated there. So this is kind of cool. You can imagine that tonight in my hotel room, if my computer knows I'm in LA and I want to go out to dinner with friends, I just open an application like this and then enter the criteria, and I have that information handy. If I want to know the weather, I just glance over there. We can also delete this information if we don't want applications to access our current location. And you'll notice here that our weather gadget's gone offline with respect to location, and we've also cleared our places results. So now we know that applications won't be able to access that data unless we enter it again. But what about automatically knowing the location? This requires a location sensor, or I would also refer to those as location providers, to be installed. And if I want to know what's installed, I can go to the Location and Other Sensors control panel. And this is really the central place to, oops, let's close that real quick. There we go. This is the place where you can see all of the devices that are installed that expose sensors. So I've got my Pharos GPS driver for this guy, and I've also got a preview of the Skyhook hybrid technology GPS sensor driver. So this is one of those solutions that's based on a lookup set of technologies, like being able to use my IP address or to triangulate Wi-Fi access points, or even cell tower triangulation to determine my location. So if we apply that, after that data is obtained, our gadgets will be able to access that location and will update to our current location based on the data that's propagated from this particular sensor. So now you can see we have the nice weather here in LA, which we're happy to see, 72 degrees. You can get the forecast. And we now have places that are nearby. So now if I want to find, oh, this is coffee houses. That's why we're getting Starbucks all over the place. So now if I want to find a Starbucks tomorrow morning, as I'm working through my email in my hotel room, I can just flick over to this gadget and see that location. And likewise, here, if I disable that sensor, these gadgets won't have permissions to access my current location, and they will go back to that offline mode. So that's just a quick overview from a user's perspective in terms of what you can do with sensors and specifically location on Windows 7. It's really unlocking new possibilities for applications, for devices, that kind of thing. But what I want to do next is get into the fundamentals of the sensor and location platform that we've built into Windows 7 so that you can understand what the capabilities are when working with this platform. So location devices, when they're exposed on Windows 7, are really just sensors under the covers. These sensors are supported by means of a UMDF driver, which is a user mode driver framework-based driver. These drivers are easier to implement and easier to debug, and that development activity is made even easier by what we call the sensor class extension, which is an in-box driver utility library that essentially implements common code and does security validations and other things on behalf of your sensor driver. So when you write a UMDF driver for your device and integrate it with the sensor class extension, your sensors that are exposed by a particular device, can be one or many, are then exposed through the sensor API to one or more applications simultaneously. Any sensor that has permissions can access that sensor, read properties, get data, and so on and so forth. So here I'm showing an accelerometer and a light sensor. Those are two common sensor types. And if I'm an application that wants to implement orientation awareness or maybe light awareness with the ambient light sensor to fine-tune contrast or brightness settings when the user steps outdoors or indoors, I can do that by means of using the sensor API, connecting to the sensors, finding them by category or type or even an individual ID that drills down to a specific sensor as enumerated on that system. And I can then monitor the data and make decisions about the environment around the PC so that I can optimize the user experience there. Now, fast forwarding to location devices, here we've got a collection of different location providers, which, as I mentioned, are just individual sensors. The simplest form is the default location, which is the user-entered or third-party add-in entered location data that's accessible to applications. And we might have a GPS, like I've got built in on my Asus U3, or a UPS dongle that we've plugged in. But we could also have a 3G card that supports location. And these devices are great because they can use ephemeral data over the carrier to get a really quick lock on satellites. And the level of precision with a combination of cell tower triangulation plus GPS triangulation really takes it to the next level in terms of what the location hardware can do. And then we have things like the Skyhook provider, which use software-based solutions to determine our location. And these are exposed by means of a sensor driver implementation on Windows 7. We even have a logical sensor framework that allows you to spawn these device instances without having directly enumerable hardware. But if you were an application and you were going to use the sensor API to connect to all these location sensors, you'd have to monitor when they were enumerated, when they left the system, receive data updates, and then always decide what the best data was based on all these sources of location data. So maybe based on the age of the data and the level of precision, you could always determine what location data was best and then use that data. But that's kind of a lot of heavy lifting. So by means of connecting with the sensor API, the location API does just what I mentioned, which is always monitor the sensors that are on the system that are of the location category, monitor the data, and then perform the prioritization and transitioning logic so that that sensor data from these location sensors is available to C++ apps or iDispatch clients. So we've got a lean and mean non-automation compliant Win32com API. We've also got an iDispatch interface, so if you're implementing a desktop gadget like I showed, or some other script client, you can access location in a very seamless way. So this is great, because now we have a layer of abstraction between our location sensing hardware and our location applications, meaning that we don't need these vertical solutions anymore that are a moving target, and we don't need to talk directly to the hardware. We really don't even need to care what the particular hardware is in any given instance. So let's take a look at what this looks like at runtime. So right now we're indoors, and so we're probably going to get our best location data from a lookup sensor. I showed you Skyhook. So under the covers, the location API is going to select Skyhook as the current best sensor for location data, and that location data gets propagated up to applications seamlessly. And if we then walk outdoors, we are going to give up our Wi-Fi reception, but we're going to gain GPS reception. So under the covers, the GPS sensor is going to be selected, in a sense, and we will seamlessly start to get location updates from that GPS sensor. So this is great, because we don't have to care about where the location data is coming from. We can just ask what the current location is, or request to be notified when the current location changes. It's really that simple. And if you really wanted to get hardcore about handling individual location sensors, a GPS, and get satellite count and all sorts of other data fields, you can do that. But your typical application doesn't need that level of capability. So to summarize, in Windows 7, there is a standard platform with a device-level API for implementing sensor drivers, and with an application set of APIs for sensors and for location for consuming sensor and location data. We also have a security model, which allows users to control the flow of data from these devices. And this platform does fully support simultaneous application access. So if you have permissions to access a particular sensor, you can get access to that data regardless of how many clients are running on the system. So now we can have ubiquitous location awareness and environmental context awareness by means of sensors and location devices on the PC. And we've really talked about two fundamental types of location data. We've got geodetic position, which is the position as defined on a curved surface. So that's like a latitude and a longitude, optionally an altitude and other metadata. We've also got civic address data, which represents some form of an address. That could be a zip code, could be a country code, could be a complete address. But what about .NET? That's a question I get frequently. What about .NET? And up until today, our answer has been, write .NET interop code. It's not that bad. Well, if you've ever written interop code, you've probably realized that it's easy to get subtle bugs. It's more difficult to debug. But all of that has changed now, because in Visual Studio 2010 and with .NET 4, you've got a location API built in. So now if you're writing .NET 4 applications, location awareness is even easier to implement, because you've got the full power of .NET at your disposal. So let's see how .NET builds on the Windows 7 sensor and location platform. Essentially, we've written the interop code for you. The .NET 4 location API is built atop the Win32com API that's inbox in Windows 7. So just like Win32com or iDispatch clients get seamless access to the current location of the device or PC, now .NET clients have that same streamlined developer experience. And these applications can also request permissions for sensors implicitly, and I'll show more about that when we do our coding demo, so that they can access these location devices if the users give consent. So we've got a new assembly now in .NET 4, which is the system.device DLL assembly. And this assembly is meant to represent the device or PC. And so since the location of the PC is a fundamental form of data that describes the PC, it's the first API to go into this new assembly and new namespace, which is the system.device namespace. It is installed by default on .NET 4, all SKUs, and is fully integrated like the other base class library types in Visual Studio 2010. So using this location API is pretty much the same as using any of the other built-in types in Visual Studio 2010. So let's walk through the core object model. These are sort of the high-level objects that you'd be interacting with when you write a .NET 4 application that implements location awareness. The root object is the geolocation provider. This is a value type that you create an instance of to get access to location data, to receive status updates, and so on and so forth. And a geolocation provider has two primary properties of interest. The first is the geolocation object, which represents the current location of the PC, which can have the form of a geocoordinate or a civic address or both. So the types of data that we looked at are both supported, and at any given time, you can check to see if either of those or both of those types of data are available. The geolocation status object and property off of geolocation provider specifies the accessibility and the availability of that location data. And by accessibility, I mean whether or not we have permissions to access location data. And by availability, I mean whether or not, if we have a location provider installed, that location provider that's currently selected has valid location data. So let's walk through these objects and learn a little bit more about the properties, methods, events, and members. So as I mentioned, the geolocation provider has a location property and a status property. There's also a movement threshold property which we can use to filter location updates. So if we want to have to move a certain distance before we fire that event, we can just specify that movement threshold, and the filtering is done on our behalf by the platform. We have a couple geolocation provider constructor overloads. We have a default parameterless constructor that creates a geolocation provider with default settings. And then we have an overload that allows us to specify a desired accuracy. So if we need high accuracy data, like if we're implementing a navigation application, we can do so, perhaps at the cost of some battery life and performance. If we don't need high precision location data, we can go with the default location accuracy, which can be optimized on a per device and per platform basis. There's also a combination of state methods here where we can start and stop an internal started state on the geolocation provider. So when we call the start method, a couple things happen. First, if we don't have permissions to access the location device that's currently selected, the user will be prompted as to whether or not they want to enable that device, and we'll see that in the coding demo. Second, if we have permissions, the application can then access the location property, and it will also receive location changed events when the location has changed. And of course, that does depend on what your movement threshold is set to, if anything. And the stop method is the inverse of the start method, meaning that it will cause the internal state to go to stopped, which means we won't be able to access the location property and we won't get location updates. And there are two events of interest. Location change fires when we have new location data, and status changed fires when the accessibility or availability of the location data changes. And finally, this class implements iNotifyPropertyChanged. So it's very easy to data bind to the properties exposed by a geolocation provider. So next, let's walk through the location data types. First, at a high level, we have geolocation, which, as I said, represents the location of the PC at any given time. There's a heading property, which is an optional property which can specify the direction of travel. A speed property, which is velocity minus the direction. And then we have the coordinate property, which is our geodetic position, latitude, longitude, optionally altitude. We have our address property, which is, exposes our civic address data. And finally, we have a timestamp property, which specifies when the location provider determined our location. So we can keep track of a history of our locations if we're saving the objects off, or just look to see how old the location data is, that kind of thing, and optionally use it or not. We have a few constructor overloads. I won't go through those individually, but those allow you to specify default values for the properties on this object. And then we have an unknown member. which you can compare geolocation objects against to determine whether or not that geolocation object contains valid data. And what that really means is, do we have a valid coordinate or do we have a valid address? If we have either of those criteria met, then we will not be unknown. The geocoordinate property, again, is the geodetic position. So we've got our latitude and longitude properties. We've got a horizontal accuracy, which would give you an error radius around your latitude and longitude. We've got a vertical accuracy, which gives you the error of your altitude. So if we have a low satellite count and have a very coarse idea of what our altitude is, we could optionally use it or not, or show the user feedback in some way. And just like the geolocation object, we've got a few constructor overloads that allow us to supply default values for some of the properties here. Finally, we have an optional altitude property if that's supported by the current geolocation provider, or the underlying sensor, rather, through the geolocation provider. And we have our unknown method. So if you have a geocoordinate, you can compare it against unknown, and that will determine whether or not you have a valid latitude and longitude. Those are the two properties that are required to have a valid geocoordinate object. The civic address class is a little bit more simple. We've got string properties for each of the address fields, which corresponds to the fields that you saw in the default location control panel. And then we've got a single constructor, which allows us to either supply string.empty or a valid string of length greater than 0 for those individual properties. And again, like the other two location data types, we've got our unknown property, or member rather, that we can compare against to see if we have a civic address object with valid address data. So let's take what we've just learned and look at what it looks like to implement location awareness in an application. And what I've done is started with a WPF application, which is called Suburban Fork, kind of a really unique name there. And what this allows us to do is to pan and zoom on a map and click on a flag to select the ethnicity of food that we're interested in. So let's see what our application looks like before we add location awareness to it. So I've got Visual Studio 2010 open here. And when I open it, I'm defaulting to downtown San Francisco. Why? Because there's a lot of restaurants there, I guess. So we've got these flags here that we've got this nice fisheye effect on. And we can just select one of the flags, click on it, say we're interested in Indian food. And then we see nearby restaurants. And in this case, maybe we want to go to the Indian Palace, for instance. We can click on another flag, and okay, it looks like we have more Mexican restaurants in that area. And that allows us to browse a different type of ethnicity of food. And we have this globe over here as well, which is a little bit forward-thinking. We haven't added location awareness, but this will show us how our location is being determined or used. So that's our starting point. And I want to talk a little bit about that, how the app has been architected so we can understand what code we're adding. If you're familiar with the model view controller or the model view presenter patterns, WPF has a similar WPF-specific concept called the model view model approach, where you have a model that represents the data that your application is going to show the user. You have a view that knows how to render specific content to the user. So that's our UI in this case. And then we have an abstraction of the view that basically knows how to interpret the model and then cause it to be rendered by the view. So in this case, our model is location. And it's a bit simplified, but currently we've got our hard-coded downtown San Francisco location. And what we're going to do is add a geolocation provider to our model. And so what we'll do is just have to write this code in the view model because we've basically encapsulated all of that functionality in the view model. So first, we're going to hook up the system.device DLL, add an assembly reference. And we're then going to wire in a geolocation provider and look at data updates and status updates. And then finally, we'll talk about optionally prompting the user. So we can either decide to prompt the user or not, depending on how much we want to interfere with their workflow. So let's go back over to our Windows 7 machine and take a look at what our location view model looks like currently. So we implement iNotify property changed because our view data binds to this view model. And in order to implement that functionality, exposed a few properties of interest here. We've got a current search string property, which when set causes a search to be executed for restaurants. We've got a current location, which when set causes our map view to center around that current location. And finally, we've got a globe state, which represents how our location is being used or determined. And then we have our iNotify property changed implementation as well. So that's where we're starting with, and in the constructor you can see we're starting without an active search. We're setting our current location to downtown San Francisco, and we're showing a not supported globe state. So let's start to look at what it's going to take to add location awareness. So we're going to go to References, we're going to add a reference, click on the .NET tab, and then when we scroll down, we will see system.device in that view. So now we can use the new location API. Next thing we need to do is add our using directive to scope our namespace. Oops, not using namespace. System.device.location. So the location sub namespace is the namespace where all of our location objects are defined. That will allow us to use any of those objects in the application. So first, we're going to add a private geolocation provider object. And this will allow us to hang on to our geolocation provider reference so that we can use this object over the lifetime of the application. Can you zoom that up a bit? Oh, sorry. Yeah, let's go to 150%. Is that better? Sorry about that. So in the constructor, we're just going to add our initialization of that geolocation provider reference. And again, we have two overloads that we can pick from. Here we're going to use the default accuracy, which we get by default there. And after we create our geolocation provider, before we can use location, we need to start it. So now when we call the start method, if we have location data and we don't have permissions for that data, the user will get prompted to enable that sensor. And we will then be able to access the location property and get location updates. But when we start the geolocation provider, if the location is already known, that location change event will be fired. So we don't have to do a synchronous centering of our map view in the location in the constructor here. We can just do that in our location changed event handler. So let's add a location changed event handler. And instead of throwing not implemented exception, what we're going to do here is we're going to look at whether or not we have a valid geocoordinate. Because we're not dealing with address in this particular application, we only want to recenter the map view if we have a valid geocoordinate. And that's passed in the event args. So we're going to say here, if e.location, which is our event arg, the current geolocation, does not equal geolocation, geocoordinate. We need to add the coordinate here. If the coordinate does not equal geocoordinate.unknown, then set our current location to a new lat-long object, which is the data type that we've defined internally for geodatic position. Now, of course, if we had built this from scratch with the location in .NET 4, we'd probably just be using a geocoordinate there. So again, we're going to access the location coordinate latitude here and the longitude. So now, when our location changes, our map will center on that current location, and then when the user clicks on the flag, they'll get restaurant results for that location. So we still haven't handled status updates. We have our globe that's going to give the user visual feedback when our status changes. So in order to implement that functionality, we can look at the status changed event. And here what we want to do is handle each of the different geolocation status states, essentially. And instead of having you watch me type individual case statements, I'm going to show you a cool new feature of Visual Studio 2010. So we can type switch, then tab, and then type what to switch on. So here we're going to access the event args.status. And now if I hit enter, voila, I've got all my case statements. I love it. And what we're going to do for each of these location statuses is set our globe state to a globe state enum value, which we've defined in our application for the different ways that our location is being determined or used. But again, instead of having you watch me type all that, I'm just going to copy this. And so our first geolocation status is disabled. And this gets raised when the sensor and location platform has been disabled by group policy. So in an enterprise environment, for instance, your domain admin could disable or enable the sensor and location platform by group policy. And if we are disabled, what we want to do is show not supported. So the user will basically see the same thing that they saw before we added location awareness to the app. And then we have the initializing geolocation status. And this means that we have a location provider, we have an underlying sensor, and that sensor is actively trying to determine our location. So if we have a GPS device, maybe we're trying to lock onto satellites. If we have a software provider, maybe we're doing an asynchronous web request to get our location out of a database, for instance. So in this case, since we're writing a WPF app, I'm going to show some spinning arrows superimposed over our globe to give the user that visual feedback. And then, if our GPS, for instance, was initializing, but we're in the parking garage and we don't have GPS reception, after a while it will go to a no data state, meaning we tried to determine your current location, but we just couldn't. In that case, I'm going to superimpose a red X over the globe. And then we have the case where maybe we prompted the user to grant permissions for the sensor, but they said no. In that case, we have the no permissions geolocation status. And in that case, we're going to show a padlock over the globe, which gives the user the information that there is location data available and it's actionable for them to go to the location and other sensors control panel if they want to enable that sensor so that their application can use that data. Finally, we have the ready status, which is what we hope to see most of the time. And in that case, we're going to show a green check superimposed over the globe. So we've added an assembly reference. We've wired up a geolocation provider. We're now listening for location changed events, and we're listening for status updates as well. So let's run the application now and see what it looks like. Okay, so here's our enable dialog, and you can see enable this location sensor, Skyhook wireless location sensor. So we're going to say yes, and that's going to cause us to have to elevate, since that's a secure operation. And now there's our fancy spinning arrows. So now the user knows if they want to see their location update automatically, if they just wait a little bit, it will. So now Skyhook has determined our location. We are in Los Angeles, right at the LA Convention Center, which is good. And we can see that that location is current. So now we can click on one of these flags and get restaurant information in our current location. So we're basically saving the user the steps of having to either type in a location or a nearby point of interest, or pan and zoom on a map, which can take quite a while when you're waiting for tiles to load, and show them things that they probably want to know, which are nearby points of interest. But if we pan our map here, we may start to see some interesting behavior. What's happening here is Skyhook is continually giving us updates based on the Wi-Fi access points around us. So we might be moving a foot or two, but we probably don't want to prevent the user from panning their map view because we really haven't moved a significant distance. So in order to filter that out, what we're going to do is set the movement threshold property. So we've got movement threshold as a double floating point value, and it's expressed in meters. So to pick a value, let's say we have to move more than 100 meters in order to update our current location. So there we are in LA. Let's say we're going to be driving a little bit north. Now we can pan the map view up and not have the map constantly shifting around on the user. But if we do get a location update more than 100 meters away, it will automatically update. So the user could pick that value, or you could intelligently pick that value. But the last thing that we want to talk about here is what if we don't want to prompt the user? What if we see that as an invasive activity? What we can do, first we're going to go to the Location and Other Sensors Control panel. And what we're going to do is disable the Skyhook sensor, because it might have been disabled when we started up our application. And what we'll see is, again, like when I first ran the application, if we ran it without changing the code, it would prompt the user. So if we want to prevent that from happening, all we have to do is surround our start call on a conditional check on the status. So if the provider.status does not equal geolocation status.nopermissions, then call start, and only then. So if we run our application again, boom, we're back in San Francisco. We just fell back to our default. So if the user wants to use location in this application, they're just going to have to enable it on their own. So that might be a simple example, but this gives you an idea of what you'd need to do in terms of developer activities if you wanted to add location awareness to your application. And to summarize what we've got in .NET 4, we've got this new system.device DLL. That's where your location functionality is. You use the system.device or system.device.location namespace, rather, if you want to access the location objects. And this is a Windows 7 light-up feature, meaning that on Windows 7, you're able to create a geolocation provider and get location data. But on down-level platforms like Vista and XP, you will be able to create a geolocation provider, but you won't be able to access your location because we don't have a sensor and location platform on those down-level operating systems. This .NET 4 API is fully functional and provides seamless simultaneous application access to the best estimation of the device's current location as implemented in Inbox and Windows 7 with the sensor and location platform. And I really feel like this is a great step forward for .NET, because now you don't have to write .NET interop code, and you can just wire up your .NET applications if you're using .NET 4 with this new API. We do have some changes coming up, however. In the RC build, we'll be introducing a few changes. We're going to have some naming changes, and there will be a difference in the way that address is accessed and exposed. There will be a separation of the accessibility and availability of the sensor location data. So there will be separate status and permissions properties to check there, and some other minor changes as well. So just know that there will be some changes if you start using the Beta 2 build to update when RC comes out. and those will be compatible with RTM. So what can you do? Well, the first thing is install Windows 7. Are any of you guys running Windows 7 already? Pretty good, huh? The next thing is to install Visual Studio .NET 2010 and .NET 4. And then think about ways that you can add location awareness to your existing .NET 4 applications. Or even think of new applications that you could write with our platform. And if you do get involved with this platform and start to play with it, feel free to give us feedback, because we'd really like to know what you think of this platform and know if there's anything that we can do to help you implement these solutions. So a couple resources I want to point out. First is our Windows Hardware Developer Central site. And this is kind of the landing page for sensors and location. If you want to know how to write a sensor driver for a location or other sensor device, if you want to access our developer forums or read our documentation, this is a great place to get started. You can also contact us directly by using our external inquiries alias. We've got this lokext@microsoft.com. By all means, feel free to use that, or come up afterwards if you want to talk with me. I can give you my contact information. We can help you get started with this platform or other sensor-related technologies. So thank you very much. With that, I'd like to open it up for questions, if anyone has questions at this point. Yes?
Just had a question regarding security
Uh-huh.
and profiles. If more than one person was to log into the OS, would it determine a separate location for that individual?
So the question is security profiles and multiple users, and whether or not there would be separate locations for different users. And the answer is no. The sensors are a system-level notion, but you can ascribe per device, per user account permissions. So that would allow you to, for instance, enable applications to access a sensor on your user account, but not on your child's, for instance.
Yeah, I was just curious about that. If there was any notification or some kind of log that would determine that the data was transmitted.
Actually, there is. I'm going to flip over really quick to my demo machine. There's actually a systray icon here that, if you click on it, it will take you to the system event log, and that shows you when your location was accessed. So if you really want to know what's going on with location, you can check it in that way.
Any plans for the sensor API extension? Managed?
Oh, in .NET? I can't really speak to that. We do have the Windows API code pack has sensor interop code for you there. We also have the MSDN code gallery samples, which have the raw interop implemented, and then some .NET games and other apps as well.
Is any of these code examples available?
This code is not available, but the code for the default location add-in, where you can click on a map, is available. So that shows you how to set the location. And we've got a location in the Windows SDK. There is a location-aware gadget, which just centers a map view for a desktop gadget. Yes? The question is, can you access the location from JavaScript? And the answer is yes, if the app, the host, has permissions. And that would be through the iDispatch interface.
Okay, so that's pretty much the way to do it with web apps, is just with JavaScript.
Yeah.
Or can you do it with Silverlight as well?
Silverlight does not support it yet. Yep. Yes?
Could you keep track of multiple devices in different locations?
So the question is, can you keep track of multiple devices in different locations? That's not one of our core scenarios, but you could implement such a solution with the logical sensor framework and remote sensors. So if you had a way of transmitting the location data, you could, for instance, have a remote location sensor and then have that sensor show up through the sensor API locally by means of this logical sensor driver instance running.
This API could support it. If we have the hardware and the driver, this API will support it.
If you have a driver that is UMDF and integrates with the sensor class extension, then it will work through this platform. So you might have to update your driver. Yes?
So you have an offset property. Do you keep history of when the location was changed? Do you keep like a browser?
No. The only thing that we keep track of in the OS is when location was accessed. So we're not storing that location data in the platform or in the operating system. We're not transmitting that location data. Yes?
You have a regular kernel mode driver. How do you work with this? Do you just layer the user mode on top?
Yep. Yep. Actually, that's how our inbox ambient light sensor driver works, because it goes through ACPI. So we've got a kernel mode ACPI ambient light sensor driver, and then we've got a user mode ambient light sensor driver, because we need kernel mode to access those internal ioctals on the ACPI.sys port driver. So that would probably be a similar type of architecture that you'd have to implement.
Becomes a filter driver at that point then, or something?
Yeah, however you want to load it, such that you can talk between your kernel mode driver and your user mode driver. And if you want more info, actually, I can give you my contact info, and we can help you with that, because we've got some members on our team that are good with this kind of stuff. Yes? The question is, can you have multiple defaults like home and office? The answer is there's only one default location at any given time. So when you set it with the default location control panel or an add-in, that becomes the default fallback location for that particular device at any given time. Yes, back there?
Yeah. You comment, please, on the commonality of the technologies you're using here with the new CLR classes that came about as a result of the geospatial types in SQL, and whether or not it supports things like well-known text and spatial reference ID. Is there a path to bring those together, and also like the order of lat long and the other current issues in geospatial?
So those are not currently married together, but there's a lot of people at Microsoft looking at locations, so we may see something in the future. I can't really comment on anything specific about that type of technology. Down here in the front.
Is there support in this class library for anything other than just the location, such as routing or navigation?
So the question is, are there other data types that are supported other than just your location in this platform? And the answer is that the sensor API is fully extensible. And since these running devices have sensor drivers that are loaded, what you'd have to do is define your own sensor data type. And then if applications knew about that sensor data type, they could get it through the sensor API. And I believe there's also a way via the location API, the iLocation interface in COM, to get extended data fields as well. So you could do that, but it would be a proprietary extension. Down here?
Is the sensor API also available in .NET 4?
So the question is the sensor API available in .NET 4? And the answer is no. To the previous question, we have the Windows API code pack, interop samples, and we also have on our MSDN code gallery site some interop code and applications that you can use. Yes, down here? It's got to be running on Windows 7 embedded or greater. So it's got to be the full Windows 7 kernel to support this particular platform. But the sensor platform is fully supported on Windows 7 embedded. So if you have a platform that is running that OS, you can use the full sensor and location platform functionality. Over there? Absolutely, yeah. And since images support EXIF metadata, you've already got that metadata, those metadata IDs defined. Geotagging photos is a great example of how you can add value to images or other data types. Now with other data types, you'd probably have to use another type of metadata schema, like the XMP metadata format or something like that. But since EXIF has the latitude and longitude values defined, that would be a good, cool scenario to implement. Down here?
Can I have the development kit?
You can. We've got a winner. The development kit is out of the house. Cool.
Can we get a copy of the sample?
So this sample is not available for consumption because I actually want to use the Bing web service API instead. I had to put this together with a web browser control and some JavaScript interop. So if there's enough interest, maybe that's something that we could make available. Something like this, with a more streamlined, integrated, .NET experience.
but not currently, sorry.
But GPS devices, does any GPS device work or any driver?
So the question is, does any GPS device work? And the answer is any GPS device that loads a Windows 7 compatible sensor driver. So we're working with a bunch of our partners on getting support for this platform. And be it a GPS puck or built-in GPS, if there's a Windows 7 sensor driver in place for that location device, you will be able to use it.
How about Windows Street and Maps?
Streets and Trips does not support the platform at this point.
Does it ever transmit the longitude and latitude?
So the question is, does it ever transmit the latitude and longitude values? And to make it clear, we don't store in the operating system or the platform the location data or transmit it, only to applications that have permissions.
So the map where it's geographically positioning you where you are, it's not transmitting?
Well, the map could transmit your location data because it's just got the data then. But the underlying platform does not track you, store your location, or transmit your location. So essentially, you need to trust the application that you're granting permissions for. Your app can do that.
But theoretically, your longitude and latitudes can go across the network.
Sure. Yeah. I mean, applications and operating system admins can do.
Did your legal team review Privacy Act?
Yes. Yes.
Oh.
So I won't get into all the privacy issues here, but yeah, that's definitely something that we're aware of. So over here. So the question is, do you have a virtual driver that would talk to something like a Windows mobile phone and get location? Currently we don't, but that would be a great driver for a developer to write using the media transfer protocol or using some other way of interfacing with the phone, over Bluetooth or whatever protocol you want to use. That would be really cool. Yep, just come up afterwards. All right, well, thanks everybody. Hope you have a really good rest of your PDC.